I'm getting ready to install a replacement head on a Jeep 4.0 engine. This is a 7120 off, and I'm going to put a 7120 back on. Never miss the opportunity to show off some good cracking on the Jeep 4.0 heads. Cylinder 2, crack here, going all the way into the exhaust valve seat. A crack between the exhaust valve seat and the intake valve seat. Another crack here. Erosion on the in-cast exhaust valve seat. Damage to the intake valve face. In cylinder 1, a crack here. And look at this divot on the intake valve. This is a testament to the reliability and durability of the Jeep 4.0. This engine still started and ran like a champ, with a little backfiring once in a while. And this Jeep was running so well, I actually was thinking I was having an O2 sensor problem. You could smell fuel in the exhaust. And this exhaust valve is in good enough condition, I could almost reuse it if I wanted to. It's really unbelievable. Look at this damage. Unreal. Before I put this new head on, I've been thinking about what I've done up to now, and I rotated this engine and made sure I didn't have a dead cam lobe. I watched the lifters articulate up and down on each of the 6 cylinders. But going through a mental checklist, I've decided I need to pull all of these lifters out, clean them up, and take a good look at them. Okay, we've had this head off for a little longer than I was expecting. I'm gonna have to pull all the lifters up and make sure they're nice and clean. You see that debris on that one? And that'll give us a chance to inspect the cam also. Okay, there's a special tool you can buy, but this engine's very forgiving. See that debris? You can't put a head on with debris on the lifters like that. So check all 12 of them. Okay, this one, normal wear on there, but the camshaft strikes this lifter on this face right here. So the camshaft is rotating at half the speed of the crankshaft. So whatever your RPMs are, divide it by 2. And that's how many times this is getting struck on this face in a minute. So the camshaft is rotational energy. And this lifter, by getting struck on this face, is converting that rotational energy into linear energy. And then it transmits that energy to the push rod, which transfers that energy to the rocker, which transfers that energy to the valve stem. And then either the intake valve opens, lets in air-fuel mixture, or the exhaust valve opens and allows the byproduct of combustion to exit. So that's what this little fella's for. And there's normal wear. So this is going back in. You'd want to change a cam anyway if you're going to change the lifters. But in an emergency, you can certainly just change the lifters. Okay, I'm working on my fourth lifter now, and I realized I need to get the proper tool for this. Using a pick and a screwdriver is taking quite a bit of time. So I'm trying to figure out a situation that would constitute an emergency and this is a lifter I have where there's a nice divot in it, but honestly, if you come across one of these, you might want to just bag it and get a cam and lifters. So the only situation I could think of that would be an emergency would be if somebody stole this set of 6 lifters while I went inside. That would be an emergency. This is a step you don't want to skip over. Well, it was taking much too long to get the lifters out, especially as I worked back toward cylinder 4, 5, and 6. So I went and bought this. This is the correct tool for the job. Also, with this tool, the chances of damaging a good lifter, that probability is reduced with this tool. Here's how this tool works. This is threaded, and there's 4 prongs on this grabbing portion. What it does is fit into this lip right here on your lifter, and then as this rod, this threaded rod, enters the prongs, they spread apart. So this is essentially just a puller. Alright, on our Jeep 4.0 lifters, you don't need this slide hammer part. So you can just remove that. You know, a piston that builds a ridge in the block and then you can't get the piston out, that's the same concept with this. I've never run across that with the Jeep 4.0. You can usually just get them out. So this tool, right-handed threads drive the threaded rod into the prongs, and then it spreads it. So with your hand you can turn it, see that? But nothing's easy in life. And you're going to be working in the galley of the block. So you can't really get your hands in there. So you're going to reach in with a 7/16 and hold that. All right, so you're going to put the tool into the galley, place it into the lifter, and then with your 7/16 wrench, turn this clockwise, spread the prongs, and then the lifter will come out. If you do run into a situation where there's a lip formed in there, the slide hammer feature will allow you to pop it out. The 4.0 liter engine is very forgiving. If you drop something into the galley, it's going to stay right there. Okay, I'm going to spend a little time and clean this galley up really good with some rags and get all the sludge out of here. So this block is cast iron. AMC, American Motor Corporation, designed this in '87, and I believe this engine is why Chrysler, who wanted to get into the SUV market, decided buying Jeep was their best way to get in there, because this is such a reliable engine. And actually AMC based this design on something they got from Nash. But I am gonna clean this up, and where I'm going with this is there's passages in the galley that go back to the crankcase. Right there's one. You skip 3 lifters, and there's the next one. Then you skip 3 lifters, and there's the next one. And then you skip 3 lifters again. And then there's 3 openings into the crankcase in a row. And then what's different from the front, is there's no passage in the very back. So the way this sits, obviously the oil must have been collecting back here in the back, and then the engineers changed the design of this cast iron. Now that's just my working theory on why this is like this, but it would make sense the way it's tilted, with the front elevated a little higher than the back, that oil was collecting in here, so they ended up opening more passages back there. If you choose to clean the galley up the way I'm going to do, I suggest you do that before you pull the lifters and clean them. Otherwise you're going to get debris back into the sockets on your lifters. So there's little pockets in here in the cast iron where oil just collects and sludge forms, and it can get pretty nasty in there. And the 3 openings in the back, the opportunity to drop something into there exists, so be cognizant of that. Okay, here's what I'm talking about with the buildup in the little pockets. See that debris? See how I just launched it into the lifter? Yuck. Boy, I'm grateful for these 3 openings back here in the back. They would sure be difficult to clean up. And then you know the joke about the 10mm socket where you always lose it. Those 3 openings back there will definitely allow a socket to drop in there. Maybe not a 10mm. Okay, that looks good. I know how a dentist feels now. All right, let's show this tool in operation. Place it in there. You get it in the lip of that lifter. Put your 7/16 in place. And then this turns clockwise. And your lifter comes out. That's a beautiful thing. Having the right tool for the job definitely applies in this situation, especially when you get back there to 4, 5, and 6. Okay, with the correct tool for the job, all these lifters came out in about 5 minutes. Actually, I think I have one of these lost somewhere in this garage. So some of these are really rough, like that one. If you were just to throw your head back on there and drop your push rod into that nastiness right there, you're going to run into some problems. Okay, you want all these lifters to go back in the same location because the cam lobe is wearing with the lifter. And then real quick, if you're thinking about changing out a cam, remember, the cam is this long. It has to fit back into all the different bearings inside the block. And with the engine installed, you're not going to be able to pull that out the front. Okay, I'm going to do a detailed inspection of each of these. Now that they're all cleaned up. So that is the ridge, I believe, that could perhaps build up. Looks like it never rises completely that far, see? And I do feel a little ridge under my thumbnail on that one. Okay, with brand new lifters, it's a good idea to soak them in oil to make sure they have enough lubricant, because the manufacturer lubes these up essentially just to prevent rust and corrosion. So a way you could make sure there's oil in there is when they're immersed in oil, you actuate the plunger with an old push rod. You could use a screwdriver or any tool that would get in there, but you don't want to damage the face of that. So the best thing is just an old push rod, or the push rod that came out of the vehicle in that spot. Okay, I'm no scientist, so together let's try to figure out how this is working. We got oil inside here, and this is a plunger and spring, right? So if that's pressurized oil, and the cam hits this and it comes up, that pressurized oil and spring is going to dampen out the motion up. That energy is transmitted to this push rod. This push rod transmits it to the rocker, and the rocker transmits the energy to the valve. Okay. So this is the lifter body. There's a little clip in here. Okay, you saw me lose that spring, so this still has pressure on it. Okay, this is called the plunger. And there's the spring. And in the plunger is a cavity for oil. Here's how the oil gets into there. And that plunger is riding in the lifter body. And oil is pressurized in this groove. So oil pressure gets into that opening, fills the cavity of the lifter. This plunger's riding in there. It can come through this hole. Then we have a metering plate, and then that's called this plunger socket of the lifter. So my old pickup truck has a Chrysler 318 poly in it. And a friend of mine and myself, we would debate every time I'd press the gas and you'd hear a clattering in the engine, whether it was bad octane fuel causing detonation, or are my lifters so worn out that they're not dampening out the kinetic energy to cause the valves to open? I don't think we ever figured out what was causing that poly 318 to make that noise. But when the gas pedal's pushed to create more power, there's a higher pressure in the combustion chamber, so it's harder for the valve to open. That or a detonation that forces the valve up. And this is the argument we'd always have, is removing the clearances from everything. And that's what this lifter is designed to do. So this lifter, we talked about the rotary energy of the camshaft being transmitted to the linear energy required to open the valves. All those different metal-to-metal contact locations, that's called valve lash. And you want to eliminate that valve lash to have the whole thing be more efficient, prevent damage, and also reduce noise. Noise, people can't hear the radios, it causes fatigue. It can really cause you to have a headache too. So when a lifter fails mechanically, you can imagine you're going to hear some noise, aren't you? Then on the Jeep 4.0, that little ticking that you hear and then it goes away, that's usually an exhaust leak. A collapsed lifter with what we just looked at, if it sounds like your valve train is rattling around, then start looking at a lifter. So here's some rocker failures that can cause some noise. These aren't 4.0 rockers, but you get the idea. Wear in the rocker. Or a noise that's really loud for a little while and then it just goes away. I'm going to do a final inspection on all the cam lobes. To turn the engine over, I got a 1/2 inch drive with a 3/4 socket on there. That will fit on the bolt on the front of the crankcase. I'm at top dead center. I know that because both of my lifters are recessed in the valley. And that little mark right there on that crankshaft pulley is lined up with the 0 mark. Okay, we're in neutral. Double check that. When you're doing engine work and you have a bunch of things disconnected, you may be able to turn the engine over with your transmission in park. I've done that and completely destroyed a torque converter. Okay, I'm going to make sure my cylinder walls are lubed up real good. And then I got this head here for a reference. So the firing order is 153624. Exhaust, intake, intake, exhaust. Intake, exhaust, exhaust, intake. Exhaust, intake, intake, exhaust. You're never going to remember that. Write it down or have your head out here to look. Okay, the rotation of the engine is clockwise, looking at it from the front. Don't rotate it counterclockwise. You could damage things. Three-quarter socket on the front of the crankshaft. Okay, there's number 1 coming up on the compression stroke. So there's a cam lobe on number 2 intake coming around. And that's essentially what I'm going to do on all 12 of these. Take a good look at them. And there's that fir needle that just happened to be on that cam lobe that I selected to film. Unbelievable. Used a little Vaseline there with some sticking properties and yanked that out of there. Okay, all my cam lobes visually look good. 5 and 6, I needed a inspection mirror. It's not easy, but you can do it. And I need a better inspection mirror than this. Okay, a little more cleanup that I identified with this, and then the lifters are going back in. All right, time to get these lifters back in. They're all cleaned up, inspected. I'm going to definitely use some assembly lube on these. Cam lobe strikes the bottom of these lifters. Now I need to make sure I put them back in the correct order. Let's see how I mark these. 1 1 2 2 3 3 12. Okay, we'll give each one a final inspection. Put a little bit of lube on there. Looks like the egg carton's not the cleanest thing in the world. Sure is nice having the correct tool for the job, I'm telling you. Okay, when the head came off of this engine, I inspected the cam by rotating the engine clockwise and watching the lifters rise and then fall, the intake and exhaust. Once I determined I had good cam and lifters, I moved on to procurement of a new head. While we're here, we also inspected all the cylinders and pistons. Our visual inspection identified the bottom end as still serviceable. Final inspection of the block, getting ready to put the head back on, I identified that there was a lot of debris in the lifter sockets from the maintenance I've been doing. I've kept this covered up, but that didn't stop the debris from getting in there. So we removed all the lifters, inspected and cleaned them, and while everything was out, we rotated the cam, looked at each lobe. I'm happy. I'm ready to put my replacement head on. I got the number 1 cylinder back at top dead center. This is the best time to do that. We'll be torquing the rockers. To do that, you start out with number 1 at top dead center. Okay, that's it.